The session has started, Amir? Just confirmation.
Yes, sir. It is started.
Yeah. Good evening, all. Welcome to this 2026 March session on for the IIT technical session. It's on offshore engineering research at IIT Bombay. We all know IIT Bombay is a great institute, and it has been doing research in offshore technologies for, from my understanding, around more than 4 decades. And very recently, I came to understand that a lot of very recent and innovative work is happening there. So I just requested Professor Behera to tell us something about it. The chief guest for today is Dr. C.P. Ramanarayanan. He's well known in the field. He is a fellow of the National Academy of Engineering, fellow of the Aeronautical Society of India, fellow of Institution of India, and he was the former vice chancellor of Defence Institute of Advanced Technology, which is university deemed to be university in Pune, as well as the former director general of Aeronautics in DRDO. He was also the director of GTRE, VRDE of DRDO, board of directors of HAL, as well as International Society for Air Breathing Engines. He has received many national awards, had in India, and areas are numerical modeling of coastal hydrodynamics, sediment transport and pollutant transport, CFD modeling for pollutant transport, and CFD applications to ships and underwater hydrodynamics. And he has got a long experience for more than 4 decades now, starting with sort of more than 3 decades, starting from Indian Institute of Technology, Madras, and then followed by postdoctoral fellow at National University of Singapore, and research engineer at Institute of High Performance Computing Singapore.
Amir, are we losing Bharadwaj's voice? Or
Yeah, no, I think there's some disconnectivity issue.
He has poor bandwidth, so I have switched off my video so that his audio at least is clear.
okay.
Amir, possibly you can continue.
Amir and as well as Bharadwaj seem to have muted their microphone.
I think, Amir, I'll take over.
Okay, sir, I think Dr. Iyengar connectivity is an issue. So what I'll maybe, sir, we'll continue with the introduction. So I think
I'll introduce chief guest and then the speaker. Then we'll
sure,
continue.
sir. Yeah, we can do that. Yeah.
So, good evening, everyone, and sorry for that trouble. Am I audible, Amir?
Yes,
Sir,
sir.
we can hear you. Yeah, great.
I am Professor Murali from IIT Madras. More than 35 years of experience, or I should say 40 years of experience in the related fields of offshore engineering. And I'm happy to be here to chair this session. Let me introduce very briefly the chief guest for today, Dr. C.P. Ramanarayanan. C.P. Ramanarayanan is a fellow of National Academy of Engineering. He is also a fellow of Aeronautical Society of India and a fellow of Institution of India. He has been former Vice Chancellor of Defence Institute of Advanced Technology, DIAT, which is deemed to be university in Pune, and former DG in DRDO and former director of GTRE, VRDE of DRDO, and also is a former board of director of HAL and the International Society of Air Breathing Engines. He has been a recipient for many national awards and had long service at NSTL Vizag. And he has guided many scholars for their doctoral degrees. With that brief introduction, I'm happy to once again say that we welcome the chief guest for this webinar. I'm also happy to introduce Professor Manasa Ranjan Behera from IIT Bombay. Welcome, Professor Behera, for this webinar, and thanks for agreeing to be here to deliver this seminar this webinar. I don't have your current CV, but I'm happy to introduce you from my memory. Professor Behera originally joined his MS after BTech in the year 2003 at IIT Madras. Then he's continued to he was one of the earliest students to convert for a PhD program, and then he finished his PhD soon after that, I think around 2008 or so, if I remember correctly. Then he spent time at various places in Singapore and in UK, and then he joined as a faculty at IIT Bombay later on as an assistant professor. 2 years ago, he has become professor at IIT Madras, and he has been championing. As we know, the offshore engineering program got wound down in IIT Bombay for a few years because of lack of resources. So they again restarted this program. Now this program is one of the most successful programs in the Indian academic institutions. I could see that Professor Behera already is crossing my number of PhD students. He is already guiding up to 18 PhD students and numerous research and consultancy projects he has been undertaking. He has also guided several postdoctoral researchers. I should say that Professor Behera has been an excellent researcher and a leader in generation of knowledge in his field. He's fundamentally a modeler, and now he also does a lot of field studies and engineering consultancy activities. With that brief introduction, I request Professor Behera to take over the floor and start his webinar. Professor Behera.
Thank you, sir. Thank you so much. Thank you for the kind words and really recalling all the dates and years of my journey. Thank you so much, sir. Just to inform the audience as well as everyone here, I am the first student of Professor Murali who joined with him. And my career in this field started with him and learnings from him. So I would like to also take this opportunity to thank the organizers, Dr. Bharadwaj, who initially called me and invited me to give this talk. So again, I would like to thank him for giving me this opportunity and thank the chair for allowing me to also deliver this presentation. I would also thank Dr. C.P. Ramanarayanan for being the chief guest of this session and guide us through this presentation and the discussions. Thanks again to Amir who actually coordinated and all that. However, the special thanks goes to all the participants, all the listeners who are there, without whom possibly I am not speaking here. So I also understand there are members of the Indian Naval Architecture Association. So Institution of Naval Architects, all the members are present. So thank you all. And there are many students who are present here. Possibly in their lecture halls or seminar rooms where this lecture is being telecasted. So once again, welcome all of them. Let me start with my talk. where I'm going to talk on offshore engineering research at IIT Bombay. Even though I have started my journey as a numerical modeler, which I still continue to do, but the horizon has increased. The dimensions in the lateral directions have increased. So some of the studies I have been involved in the field of offshore engineering. And it is not only me, it is our group, Ocean Engineering Research Group at IIT Bombay, who are working in this. So I would say that whatever I'm presenting, it is the work of the Ocean Engineering Research Group here at IIT Bombay. Before I start my technical talk, let me quickly take you through IIT Bombay. So first of all, I would welcome you all to IIT Bombay. Whenever you would like to come, we will be happy to host you. And at IIT Bombay, we have IIT Bombay was basically established in 1958, and the Department of Civil Engineering, where this specialization of ocean engineering is there, started along with the department in 1958, along with the institute in 1958. And we are actually doing well in terms of world ranking, all the QS ranking, whatever we all know. And in this, we also have various ranks in the country level and as well as within the global scenario. Well, when you are coming to Mumbai and IIT Bombay, we will also help you to visit some of the sites which are really fascinating, and we'll be happy if you can explore all this. In addition, these are our strength students who have, this is a picture of one of the year, and the graduating undergraduate students along with the faculty members. So this is again our department students, but coming to the department as a whole, we have almost 60 faculty members, and we have 7 specializations or 7 verticals. These verticals I will quickly also update. I will not spend time on this. But our faculty members have been involved in various national as well as international projects, and they have been recognized by various forums in the country as well as globally. And the verticals that I was mentioning about, we have 7 verticals starting from transportation engineering, geotechnical engineering, water resources engineering, structural engineering, ocean engineering, remote sensing, construction technology, and management. So these are 7 verticals, and ocean engineering is one of the verticals that we few faculty are working on various topics and various subjects. These are mega projects which you can possibly recognize by looking at the pictures, various nuclear facilities, some of the metro facilities, some of the airports which are large-scale facilities that are being developed. We are all involved in that. Coming to the Ocean Engineering Group, let me introduce the faculty members who are part of this Ocean Engineering Group. We are 5 faculty members. Professor Balaji, who is currently on deputation as Director of NIOT, Ministry of Earth Sciences, is not present at IITB effectively, but he is always part of our colleague faculty, and he is expected after completing his tenure. Other than that, the 4 of us are currently here. We are contributing to all the research work and the teaching and research that is happening. And the work that I'm going to present will be a compilation of many of us. However, before that, I would like to just highlight some of the different work that we do at IIT Bombay. In terms of coastal engineering, we do various physical and numerical modeling, coastal and offshore structures that we design, offshore structure, wave structure interaction studies, tidal hydrodynamics, computational ocean and coastal hydrodynamics, various statistical stochastic analysis, and neural network and subcomputing works that we do, which is application to ocean engineering specialization, and modeling of tides, storms, and tsunamis. That is again is a major domain that I work. Impact of climate change that we look at, wave, tide, and wind energy. That's also another field where we have been working substantially. Interaction between winds, waves, currents, and tides is something that we are working numerically as well as experimentally. Sediment transport and marine EIA, shoreline stability, all that studies we carry out. In addition, we also look at the water quality parameters in terms of pollutant transport in the coastal waters, oil spill analysis, and so on. So there are quite a long list. I just wanted to give a quick overview. Coming to the facilities that we have a few facilities, unlike what you can possibly expect at IIT Madras, which has quite a large number of and large facilities in terms of experiments. We have wave flume, that's a 2D wave flume. We also have developed wave cum current flume. And in addition, we have completely designed the in-house wave maker system, which is our own, and it has been already copyright has been obtained and patented. In addition, we also have recently installed and operated this towing carriage system, and that is already working and it's already being used. And just to update all the participants, we are in the process of developing a wave basin where we will be able to have a larger facility and to generate long crested, short crested waves in this wave basin. In addition, we have computational clusters for various ocean modeling and ocean applications. There are a number of field studies we do carry out as part of our research and projects. So we have several equipments to carry out field studies and field measurements. This is something I want to highlight, the recent towing carriage, which was inaugurated by our Dean Research and Development, as well as the wave current flume was also inaugurated by our Dean Research and Development. This has many capabilities anyway that we will come to know as we discuss. This is something, as I was telling, we are planning to develop the wave basin where the land parcel has already been earmarked and the work is almost about to start. Possibly within a year, we should have this with us and in operation. This is the size of that wave tank and other facilities which are going to come up at that facility. And now I would like to highlight some of the research work that we are carrying out at IIT Bombay in different areas. This is something we on marine renewable energy sector. We are carrying out studies on offshore wind energy, floating offshore wind turbines, oscillating water columns, OTEC platform analysis, then saline or energy from salt water. Then we have point observer based studies that also we carry out. So some of this I will cover in detail today in the talk. Coming to the wave structure interaction studies, we also look at various submerged breakwater, submerged reef analysis and how they work, the oscillating water column, how that works. So in addition, we also carry out experimental and numerical coastal modeling studies where we simulate storm surge and how the scouring around various structures may occur due to storm surge or tsunami kind of flows. And in addition, impact of vegetation or the nature-based solutions. That is something we also investigate numerically as well as experimentally. And some of the other type of structures we do carry out in terms of floating breakwater and wave energy device analysis in our laboratories. This is again another area where we work in terms of assessing, modeling and assessing the coastal hazards in terms of cyclone modeling and storm surge modeling, as well as tsunami modeling and flooding. So we do carry out work towards modeling as well as coastal resilience, early warning system development, and the socio-economic and policy dimension analysis of these disasters. This is again not going to stop at that. We also look at various coastal disaster risk reduction analysis, how we can safeguard the public who are going to be affected, the structures which are getting affected, the design parameters which needs to be considered for such kind of structure, and as a whole, which are the coastal locations or coastal stretches along the coast which are going to be affected due to these various coastal hazards as well as climate change impact. So having said that, we have recently signed several MOUs with the government of Maharashtra to develop some of the R&D infrastructure, to develop or to institute center of excellence for the growing field or the thrust field of ship design and shipbuilding. And we are also planning to offer, or we are designing to offer, one postgraduate program, diploma program, PGD program for the working professionals who can actually register for this course and take it and complete it to enhance their profile as well as their knowledge. So this PGD program will be on the coastal infrastructure and coastal ship design, ship repair facilities. So in addition, we have recently been working where Professor Murali is actually spearheading that to establish a maritime innovation hub at IIT Bombay, and similar hubs are also being planned other IITs, IIT Madras, IIT Kharagpur, and IMU. So this is initiative of Ministry of Port, Shipping and Waterways, MOPSW, where you can see the Joint Secretary is actually there in the picture, where we had signed the agreement, and we are going to have this very soon. Now let me come to the technical talk. When I'm talking, I would like to request Amir, please let me know if there is any problem in terms of my audio or video at any point, because
Sure,
I may
sir.
not realize that.
Yes, I'll let you know. Thank you.
Yeah, thank you so much. So now coming to this offshore engineering research at IIT Bombay, I will focus on a few topics. Obviously, I will not be able to cover everything within the stipulated time. So one of that topic I'm going to cover is floating platform for OTEC. So what is OTEC? It is Ocean Thermal Energy Converters. And what we are trying to study is a floating platform which can actually house the OTEC structure, Ocean Thermal Energy Converter structure, and how it is going to be different than the existing floating structures, and what are the challenges in that. So now diving deep into this subject, if we know that OTEC platform, it can be on a floating platform or fixed platform. So far, mostly people have been working on the fixed platform. So on fixed platform, you put the structure, there will be all the facilities in terms of the open cycle or closed cycle OTEC system. But now our challenge is to make it floating so that instead of the coastal facility, we can take it to the offshore region, and then we will be able to harvest the advantages of keeping it in the offshore location. Now let me quickly highlight 2 points. If the facility is located at the coastal location, then what are we doing? We are actually pulling warm water from the surface of the ocean and cold water from the deeper part. So this is mainly required to get the temperature gradient between two different mass of water that we are going to get. From the ocean depth, the deeper part of the ocean, when we will get the water with a temperature of around 4 degrees, 5 degrees or so. And from the surface, we may get the water with a temperature of 26 degrees, 27 degrees. Now the difference is going to be approximately 22 degrees or maybe 20 degrees and so on. Now that temperature difference will be used to extract the energy from this gradient. Now I will not get into the temperature gradient part. Now I will highlight that when we go to this pipe, go to the depth of let us say approximately 1000 meter to get the cold water, that is with a temperature of 4 to 5 degrees, then we have to really put very long pipes and go all the way to that depth so that we can get that water. And from the surface, yes, from the coastal zone, we can get surface water, but still we have to go certain distance so that we don't get a lot of pollutions and we do not intervene with the various coastal requirements and processes. So while we do that, the requirement is going to have long pipes. Now, if we put this facility in the offshore floating structure, what we will need to do? We need to simply put two straight vertical pipes, one going to just below the sea level, sea surface, where you get warm water with a temperature of around 25, 26, 27 degrees, and you have to take the pipe vertically downwards to the depth of, let us say, 1000 meter and get the cold water. Now, in this, the challenge is how do we actually have it, because this is a floating structure, and when you are having these pipes and all that, the design and the dynamics is going to be different. So we need to analyze that and see how it is affecting, whether in the favorable direction or in the adverse direction, and then how we can change the design of these floating structures. Now, there are many floating structures which are being used for various various offshore exploration studies, but it is not same here in this case, because there is going to be processes involved in that, and you will have these pipes which are not very small diameter. It is not similar to the risers which are used in the offshore platform for oil exploration and all that, which is very small. And in this case of cold water pipe, the diameter could be 4 to 10 meters, not 4, it could be around 10 meters diameter or slightly more than that. So a pipe of 10-meter diameter and pulling water from the ocean from a depth of 1000 meter, and the other pipe also of the similar dimension could be, and pulling water to this facility, they are going to affect the overall hydrodynamics and the overall performance and stability of the structure. So that is what we are going to test, or we are going to study in this work. So having explained that, we know there are many structures, floating structures, starting from spar, semi-submersible, the vessels or ships, and what are the processes that are involved? Heat exchange system, cold water pipe is going to pull, warm water pipe is going to pull the water, warm water. Then you will have mooring lines. So all these have to be taken into account when we actually design and analyze this. So in our study, what we have done, we have taken a spar. How this spar system is going to be used and can be applied for this OTEC system. Now, I'll not spend time on this. These are already known to many of you because you are all from naval architecture background. So going forward, what we did first, we actually looked at all the tools that are available. Yes, we know that we will carry out experiments, but we also wanted to do numerical studies. So we first checked what are the numerical tools that are available that we can use. And when we looked at, there are a number of tools that were available, and we could actually see that we may be able to use ANSYS Aqua for most of these studies that we want to carry out. And then we decided to go for that. We also looked at various studies which have used these softwares, and what was the limitation in their use, what was the advantage in their use. So based on that also we checked and decided on this software. So this more details on this you can actually find out from this publication, which is shown at the bottom of this, which is a basically detailed review of this work. So before we started the numerical and experimental work, we carried out a thorough review that has been published, so it can be accessed. Now moving to the overall analysis and design that we wanted to carry out for this floating OTEC platform, we wanted to understand what are the loads. So there are several loads. If you look at the design loads, you have first of all structural loads, then extreme loads, then you have environmental loads and operational loads. So when you talk about structural loads, it is quite simple to basically find out. You can have dead load, live load, thermal loads, all that, then weight of water that is going to be basically brought to the structure, the VIV, which is actually kind of hydrodynamic load, but we are putting it under this because of the cold water pipe. It is going to be acting on this overall structure, and the flow, when the water is being pulled or being taken to the deck from the deeper water, there is a flow velocity. So that velocity is going to have some more additional inertia impact, and then you will have fatigue loads which will be there. So all that is acting on the cold water pipe will also be acting on the overall structure. Then you will have the mooring load. So now, although it is very simple to write this, but individually they actually need a detailed investigation. So some of this we have done, some of this we have considered based on the previous work and previous structures, and we have progressed with our work. Now, extreme loads, one has to consider the storm waves, freak waves, and the tsunami. So they are obviously expected in the ocean. So one has to really take into account the loads and the impacts that are going to be due to these extreme events. Coming to the environmental loads, which are usual regular conditions of the sea. So you will have to consider the wave loads, current loads, wind loads, and the operational loads, which are basically the operation of the OTEC platform, that is the operation of heat exchanger, turbine that is going to be working to generate power, then the working fluid. So let us not worry about the working fluid. Basically, there are sometimes some other fluid is used to for vaporization and operation of the turbine. So that fluid is going to also play some role. Then there will be pumping system, because for so much of water coming in and out, we need a huge pumping system, and their operations are also going to affect. So all these loads have to be considered when we carry out this study. Now, what we need to do, we need to carry out the offshore floating structure. Then after incorporating all this, we'll have to do the response analysis, and then we'll finally decide whether it can be taken for energy applications or not. Now, for floating structure, what we have done, we have considered the SPAR platform. And for response analysis, we have carried out experimental and numerical studies. And finally, we also focused on this cold water pipe, because for many structures, if you see floating structures, everything else would remain same except this cold water pipe and its dynamics. So that needs more focus and more study. So that is what we have also checked in our research. So there are research gaps which we have listed here from this basic analysis. We need first need to have a comparison of spar, semi-submersible, vessel as OTEC supporting structure. Finally, we ended up with spar. Then effect of flow of CWP on the response behavior has to be understood. Then we need to carry out the coupled numerical model studies to represent the reliable actual physical behavior of the structure. Then optimization of the cold water pipe for energy efficiency. So what diameter of the pipe is going to be useful for extracting or bringing enough fluid and enough water, as well as we have to ensure that it is not affecting adversely to the structural dynamics. Then that is what basically we have to look at the intricate interplay of this moon pool, which is going to be there to take the take the cold water pipe and warm water pipe down, and the CWP as a whole on the platform motions. So finally, overall, we will look at the behavior of different OTEC floating structures in various conditions, random waves or extreme environments and so on. Now, coming to the study, this is something which I want to highlight in a nutshell. We actually fabricated the models. We did a basic tests starting from your suspension test, bipolar test, and then we tested everything. We had to make sure that this is completely waterproof. And again, just to highlight that this model, whatever you see here, was actually fabricated in our lab. It's a 3D printed model. And the 3D printer is also there in our lab, where it was printed in parts depending on the maximum printable dimensions, and then it was assembled. And while assembling, we had to ensure that there is completely it is completely proof against any leakage or any water ingression inside, so that we can carry out the test properly. And here you can see that it is moving under the waves. And this movement, I think that movement has stopped. Yeah, that's okay. So as you can see, this motion, there is an accelerometer which is attached at the top. So this is going to measure the motions, and there are other equipments which are also attached in this inside, which will give us all the scenarios, and that results are going to be analyzed for further understanding. Now, in this, one thing I would like to highlight, you can see here there are 3 springs which are attached on 3 sides. So especially the students who are possibly going to work on the similar lines, we need to represent the mooring lines. So in a small flume where depth is limited, it is impossible to actually provide the mooring lines or actual, even if you scale it down, it is not possible to have that kind of dimensions or depths in your flume. So there is a provision, and there are already established methodology to provide something called soft mooring. So there are research papers available, and based on that, we have actually applied it and we have tested it, which really worked well. And anybody who wants to know more details can actually contact, and we will be able to help. So in this, after we did the experiments, we also carried out the numerical studies, and you can see the comparison of experiments and numerical studies. Both, they are really showing quite good agreement with each other, although there are some differences which is bound to happen. And we also know why these differences are there. As I mentioned, one of that mooring system is not exactly replicated. So similarly, there are other things which are there. So in this, we found that for various wave heights or significant wave heights, what will be our response or RAOs for different parameters, response RAO for surge, RAO for heave, and pitch that were obtained. And finally, these results, as you can see, we have communicated it to a journal, and it is still under review. We are waiting for the final, we have got one round of review, but we are waiting for the next final outcome. Coming to this, the numerical modeling with cold water pipe. As I said, the initial test what we did in the experiment, it was without the cold water pipe. And without cold water pipe, if we do, the impact of cold water pipe can completely change the dynamics. So to do that, our wave flume was not capable enough to accommodate the cold water pipe, because if cold water pipe is going to be too long, the 1000-meter depth, when we scale down, still it is much higher to accommodate in our wave flume. So we started working on the numerical model. So in numerical model, we could implement that, and we did the tests and we compared our present results with all the experiments that were carried out in some of the studies, and we found they're really okay. And further, during this period, we also found there is possibility of doing the experiments. So what we did, this total mass, we actually thought we can have some length of cold water pipe and then add some mass, and then that can be simulated. However, what we are missing out here is the flow dynamics, because the length, the flow and the vibration, that is going to be completely different when we have the complete length and when we truncate it. Even though the mass part is reproduced, but the flow part and the dynamics due to the flow is not completely reproduced in the experiment. So that I will show you that towards the end, but I just wanted to highlight what challenges we are facing. So we did it. We did the numerical modeling, and with that we got the results which are quite satisfactory. And then the results also showed us how different parameters, surge, heave, and pitch, they are varying with spar alone and spar with cold water pipe. And we can see there is a difference. And the difference, you can observe that it is significant in some of the parameters. I will show you in another plot. So now moving forward, I just want to highlight this. You can see here, this is the 3D printer that we have, and we are printing the cold water pipe. And that cold water pipe is going to be used for the tests. And this is what is the test setup with cold water pipe. And we have a pit here, and within that pit, you can see the cold water pipe is still going down. But even then, we had to adjust the mass so that it can be represented for the whole length. Now, looking at the results, you can see here the surge with spar alone and surge with cold water pipe, there is a huge difference or reduction when we have the cold water pipe. And similarly, you have heave. Heave doesn't show so much of reduction, but the pitch again has substantial reduction. And this, when we plotted the RAOs, we can see clearly that the RAO for surge with cold water pipe is showing substantial reduction in its motions, and for pitch also it shows reduction, whereas for heave that's not much of an impact. So these are all critical results which will help us to move forward and fine tune various design parameters of the structure. So now with this, I think I will move on to the next topic that I want to talk quickly. That is floating offshore wind turbine. So far what we discussed is the floating OTEC platform. Now I am going to talk about floating offshore wind turbine. This is something we started working few years before. One of our student, Arya, who was working and has completed almost all the work, and she will be submitting thesis very soon. And I'm actually presenting her work. So the previous work was also of another student whose name is Nasma, and she actually worked on that. So this floating offshore wind turbine, our aim was to fine tune it for the Indian context. And as we know that two reasons have been identified, and they are basically looked at to develop and install offshore wind turbines. One is of Gujarat, another is of Tamil Nadu. So these two locations are potential reasons for offshore wind turbines. Now, when we look at off Gujarat, the depth is available certain locations, and similarly of Tamil Nadu also at some locations we have substantial depth, and those locations we can possibly go for floating offshore wind turbine, and those studies are essential. So what we did, we looked at this analysis, and first we took a model called OC3 SPAR platform to support this wind turbine. And OC3 SPAR platform is already kind of available. It's an established platform which has been studied enough. And first we wanted to carry out the experimental investigation of the dynamic characteristics of this platform under the influence of aerodynamic loading. So that is what is the additional component here. OC3 platform is there, that's a SPAR which is present, but it has not been used for the wind turbine. But if at all we want to use such platform for wind turbine, we need to account for the aerodynamic loading, the thrust, the vibrations, and the dynamics that is going to come due to the movement of the turbines, the loading that is going to come on the wind turbine, and its impact on the hydrodynamic stability and so on. So for this, what we did, we carried out the tests or the experiments using this methodology. I will not get into the steps of this. Possibly these are all standard process, but we carried out the tests for regular wave conditions with rotor thrust and irregular wave condition with rotor thrust, and all that we have analyzed and understood what are the various motion responses that are coming because of this. So moving forward, this is a typical, this is the picture of the spar with that wind turbine. You can see here, this part is basically your spar component, and this is the transition part where this connection between the spar and the wind turbine is going to happen. And this part is our wind turbine. And then on the top, you will have the rotor with the turbine. So all that we did the initial tests for its stability and all the parameters, and then we installed that in the flume for testing. As you can see here, the top is having a rotor, or is a kind of turbine which is going to recreate the thrust or emulate the thrust that is going to happen due to the turbine motion or turbine rotation. So again, for this also we used the soft mooring system, as I have explained in the previous study, and we carried out the tests. So for that, you can see here the experiments which were carried out, the motions of this structure, and you can see here, if you look at carefully, you can see also the movement of the turbine. So the fan is rotating, which will also give the thrust to the overall structure. And how this motion and behavior of this spar is happening, that was studied, and what are the actions that we can take to reduce the motions or to stabilize it, and which can be implementable. That's what is the objective of this study. So now in this, what we did, we carried out these tests, and then we also carried out the numerical analysis. So in numerical analysis, as you can see here, the mooring lines are actually going all the way down. So it is the zoomed portion, and that is seen here. And you can see here the waves propagating, and this structure, the motion is not clearly visible because of the size, but it is moving. So because of this motion and because of the actual dimensions of the mooring lines, we also investigated how this impact or how the motion of the spar is going to be. So that's the advantage of numerical modeling, which is basically a limitation in terms of experiment. So initially we did the experiment and we got initial results that were satisfactory. Then we went on to basically reduce the limitation of experiments whatever we had, and apply actual mooring length, mooring line, and dimensions to understand the structural dynamics. So having done that, then we also carried out the study for you can say the coupled wind wave simulation and LCOE analysis. So first we did the coupled wind wave simulation. So when there is a wind, there is rotor thrust and there is a movement, how this is happening. And LCOE is basically the levelized cost of energy. That analysis also is very, very important, because if we do not have the cost for unit energy, and that cost is not viable or is not affordable, then this structure or the turbine is not going to come up, because no investor is going to come forward. So we did that analysis as well. So in this, what we did, we considered an array, because when actual implementation is going to happen, it is not going to be only one structure or one tower. It will be an array of devices. So you will have number of turbines, wind turbines installed in some kind of pattern. So that pattern is also optimizable. One can optimize that depending on the wind and the energy efficiency and so on. So let us not get into that. What we have done some broad consideration. We have considered 10 diameter, 10 times the d of the rotor diameter. So if you have the diameter of the turbine as d, then the distance between one turbine to the next turbine is 10d. And similarly, in the lateral direction, we have considered 5d. So using this specification, we have considered an array, and that has been used to calculate how much energy we will get and effectively what will be the overall levelized cost. So based on that, there are two different methods which we found, and we also took both the methods to find out how we are what is the value that we could obtain. So these are the two methods. One is by Manja and one is Diaz and Soros, and both these methods we have adopted and checked. So using that, finally we could see that the levelized cost is coming something around 9 rupees or so, so per unit, per kilowatt hour. So that is slightly higher compared to what is the energy cost right now. But now it is good for me to talk at this point of time when we are having difficulty in getting oil, gas, and the news is going haywire, telling that okay, gas is not going to be available, oil is not going to be available, and so on. It is also important for us to see what are the alternatives. So this is what is the alternative. So even though the cost is slightly higher, that might still become equal if this scarcity is going to come up. Now, question is, let us not accept that this problem will persist. Even then, if we actually scale it up and we can increase the number of towers and number of facilities, and there are also studies which are going on to invest in hybrid energy extraction system. So it's not only wind. Wherever the wind is high, it is known that the waves are also possibly going to be higher. So if the waves are higher, we can also have wind and wave energy both combined, or some locations there could be wind and tide energy together. In case of Gujarat, that also is possible. So we will have to explore what are the kind of combination of energy that we can actually harvest. So together it might become more cost effective. So that is what we could really understand. But even then, the overall cost per unit is still in the acceptable range. And now, as I said, we have two locations which have been earmarked or identified as potential region of Gujarat and of Tamil Nadu. So there are locations along Tamil Nadu, also along Gujarat, where the water depth is very, very shallow. And in such regions, it is possible to go for fixed structures instead of floating, because whenever the depth is higher, in order to reduce the cost, capital cost, we need to go for floating structure, because you cannot go for fixed structure for a very large depth. So for fixed structure, we are also again working. I'm not going to present the work on that. There are certain aspects which we want to look at considering the Indian context and investigate, and then make sure that we have clear design and clear guidelines available, so that when the agencies are coming forward for implementation, it will be helpful for them. So that study is going on, and we are carrying out. Another PhD has started working on that. Now, when I have been talking about these two aspects, these are all offshore installations. Any offshore installation, we have to really check the survival condition. So, especially when you have extreme events like cyclones and storms, so these facilities are not going to be removed and kept somewhere else. They will be there. So when you know that it will be there, they have to survive. So that survival condition needs to be checked. So for that, what is the procedure? Procedure is, first of all, we have to understand what are the historical cyclone records or tsunami record, whatever has happened earlier. We need to assimilate that. Once we have that, I'm presenting for a cyclone case, let us say. So for the cyclone, we can get the records from our e-atlas from IMD and get the data. There are also other options like JTCC and other records can be obtained. From that, one can calculate the probable maximum tropical cyclone parameters. What are these parameters? These parameters are nothing but the maximum wind speed during the cyclone and maximum radius of the cyclone. So basically it gives us the intensity and the size of the cyclone. So this probable maximum is a statistical calculation which needs to be carried out. And that I'm not going to again go through that because it will take a lot of time. I'll also show you some papers from where one can actually get it. We have already published it. And once we get these PMTC parameters, then this cyclone has to be optimized for its track, because we know the intensity and size, but it can come from any direction, or its track can be coming from any direction. So considering our structure, if it comes from different directions, and we know that the intensity could vary, so what will be the maximum impact? Which direction is going to lead to the maximum impact? That we need to assess. So that optimized cyclone track needs to be obtained, and that analysis has to be carried out. Once we have this, then we go for the final coupled storm surge and wave modeling, because when the cyclone is coming, along with the wind speed, you will have surge as well as strong storm waves. So both have to be simulated. Usually we use this coupled model. ADSARC is a circulation model where we get the primitive parameters like your U or the horizontal velocity, but I don't say horizontal, both are horizontal in fact. You get the velocity in X direction, velocity in Y direction, and the elevation. So these three parameters you will get from here. So some of these parameters will be fed into this unstructured swan. Basically, this is a wave model. And to the wave model, you feed these parameters and simulate the waves. And this is a tightly coupled model. It is not like one way. So every time step, the data is exchanged among these two models. And finally, the output will be obtained. And final output will give us what is the value that we have to use for survival condition of this offshore platform. What is the highest significant wave height or period and current speed, all that we will be able to obtain. Now, this is a detailed methodology, step-by-step procedure how this analysis can be carried out. I will not spend time on that. Rather, I will request you please go through our papers so that you will get the detailed methodology. Now, this is this typical domain, what I am showing here, that is for Arabian Sea. You can see here, this completely captures the Arabian Sea domain. And here, if let us say I have some installation in this island where we have Kavarati in Lakshadweep, and I want to study that. Then what I will do, I will first discretize this model domain, and around that region where my region of interest, I may possibly go for higher resolution of the mesh and with a proper fine resolution discretization to get a better result. So these things has to be done. We have done it. And then we considered some of the cyclones that have happened earlier. So some cyclones that we could identify, they were considered. But now, first thing that we think that if the cyclone passes through that site, then we will get maximum load. So that one has to carry out, possibly if we don't know. Then after doing that, we understood that no, we are not getting the maximum surge at the site if the cyclone is passing through that, because the cyclone is always anticlockwise and the maximum velocity is going to be at the distance of R max or maximum radius, wherever it is. So if we move the cyclone slightly off and then simulate it, the maximum radius and maximum velocity might hit this location, and that is where the maximum surge may take place. So that analysis, that SIT was done first. And once that is done, then you can calculate your parameters. So your peak storm surge can be calculated and peak significant wave height can be calculated. So one thing I have not shown here, that is before doing this, we have actually taken this track and tried from different angles. So this is the angle which actually gave maximum surge, and that's what I'm showing at the end. But different chains of angles have also to be studied. Here I'm showing, to some extent I'm showing here, yes. So different, you can see different approaches have been studied and which one is giving maximum, that has been finally considered. And the final values are shown here, how this peak surge and what is the peak surge, peak significant wave height, and then peak period, all that could be obtained. So these are the parameters which will be used for analysis of the structure or stability analysis of the structure, so that even during these conditions, the structure is going to be still stable and intact. So there are discussions that can we really go for such kind of extreme condition, or we should have something which is kind of a middle ground, because anything that you do with extreme, it is going to impact your cost and overall design of the structure. So can we really go for this? So that study and that analysis is still going on. I will not be able to talk right now, but I can actually talk about it at a later stage. So anyway, I have already discussed about these things. This is again instead of Arabian Sea, we have carried out again for Bay of Bengal. So both the sites, similar studies have been carried out, and we could get some values. Now I'll highlight another study quickly. I'll possibly take maximum 5 minutes more. So this is again another study which is very, very important with respect to the offshore environment. When we are using winds for any analysis, and especially when we are using the wind for future predictions, we are most likely using the climate model outputs. And there are several climate models available. You talk about GCMs, RCMs, all of them will give output. Now, which output is good, which output is bad? So there are hypotheses which says that, okay, you take all the models and then average it out, or take ensemble of that and then use it, it will give you very good. Now my question is, if I have some models which are very bad for this site or for our region, if I use that in the averaging, it will actually degrade my results than improving. How can I tell that it will improve? No. So if I take those models which are doing fairly good for this region, then it will give me a better output. So what we did, we tried to analyze that. Instead of taking all these models and taking just ensemble of 50 models, 30 models, 10 models, instead of randomly doing something, we should have some basis for that. So what we did, we considered different variable scales. So we know that the wind that we are getting should be very good in terms of daily mean. Annual cycle should be represented properly. Annual mean should be there. Seasonal mean should be captured. Annual mean trend should be captured. So there are different things that we could really look at. When we look at, there are different methods or statistic which is there to check their uh, um, proficiency or their effectiveness. So that also we looked at. And finally, we created some kind of score, which we call it as total relative score. So this is a complete methodology we developed and published, which is being used right now by many researchers. So this total relative score is something which we calculated from all these different parameters. And this TRS is being calculated for each model. So I may take 77 or 80 models for the climate model output. So all these individual models, I will find out this total relative score and check which one is performing good or which is not performing good. So in this direction, this is the methodology. We first got the models wind data, then we did a quantile mapping, and that we verified, or this quantile mapping used the ERA 5 data, basically historical data for past several years. And then with this, we could do the bias correction and got the bias corrected model wind data. And there we have historical data from 1979 to 2005. Then we consider it as present wind for 2006 to 19. And then with that, first we find out the assessment criteria. So once we got this assessment criteria, then that we will use for future winds. So best hybrid wind input we got, and this winds data sets we will use for our future winds studies. So doing that, we could find that this analysis, when we carried out for CMIP 5, right now we have CMIP 6 data, but initially when we started, we got CMIP 5 GCMs and Codex RCMs. All that analysis we carried out, and we found that there are several models which are really doing good. And just to highlight, there are 2 publications which are listed here. And these 2 publications will give you full details of this methodology, how to calculate the TRS, how to calculate or how to carry out this kind of studies. So one can refer to that. So from this, we found which are the models to be taken. Now, quickly moving on, we also carried out the comparison between CMIP 6 and CMIP 5. And then finally, we summarized that most of the CMIP 6 GCMs show significant improvement than CMIP 5. So this is expected. And CMIP 6 is the advanced version. So we could also see that. But in that, we found that there are certain models. Let us say the first few models, they are really doing good. And if we take the ensemble of these, then that might be better. So we did it. And finally, we concluded that there are few models. You can see here the listed models, which are really good for the wind data. Here I want to put a disclaimer that this is done for the wind data. The exercise which has been shown here is done for wind data. If somebody is going to use any other data, they have to carry out similar exercise for that data set and use that appropriate model output, because different variable might be better predicted by different models. So we need to understand that. Now, this is very important piece of work, which is useful for all offshore wind analysis and wind inputs that we are going to use. So overall, if I want to summarize the presentation, what I did, we could see that there are studies which have been carried out. However, more studies are required for ocean renewable energy support structures for Indian scenario, which we are carrying out to some extent, but there are many studies which are required and other institutions are also on it. And considering the cold water pipe in Spar OTEC platform is very critical, which needs to be thoroughly investigated. We have started it, but much more study and analysis is necessary. And comprehensive modeling of floating offshore platforms are essential. And then assessment of survival condition for offshore structures are required for both Bay of Bengal and Arabian Sea domain. The wind forecast must be done using reliable winds input or wind data. That is what is overall summary I can tell from the presentation that I did. And with that, let me also sincerely thank all our team who have worked tirelessly to carry out all the research that we are actually publishing, producing, and some of that I am presenting here. My sincere thank goes to all of them. And you can see here in the front, the team that we have, the faculty members are sitting here. And with that, I would like to say Jai Hind to everyone. Yeah. So over to you, Professor Murali.
Thank you, Professor Behera. That's wonderful. Are you able to hear me?
Yes, sir. I can hear you.
Yeah, that's wonderful. And thank you very much for throwing some light into what all goes within the ocean engineering group of IIT Bombay. And also congratulations for setting up this team completely. Also,
Thank you, sir.
congratulations that you guys are also making several facilities in making. So,
Thank you, sir. Thank you.
wonderful about that. I think Amir, you would like, or Bharadwaj, you would like to take over from here?
Yes, sir. I think we can start the we can have the chief guest maybe address right away, and then we can have the Q&A session after that, sir.
Yeah. Dr. Ramanarayanan, please.
Yeah. Thank you very much. It was really a scintillating talk.
Thank you,
I mean,
sir.
lot of academic institute generally are known for more for theoretical type of research, whereas here I am able to see a lot of, hardware related theoretical work being done. Congratulations.
Thank you, sir.
In fact, how I got involved into this is because of my nearly 28 plus years of work at NSTL, where we have the high-speed towing tank, where we have the cavitation tunnel, and also seakeeping and maneuvering basin, best of that kind that is available, and with very close association with IIT Madras. These facilities, basically these facilities are used more for ship and underwater design than for, of course, ocean structures. But I also had opportunity to work very closely with some of the best naval architects of the country of those earlier days. So in fact, I also got selected in Navy. Maybe somehow or other, I was getting closely associated with ocean and ocean engineering. And that is how I think even today I continue with the Ministry of External Earth Sciences as their member in that mission management for the Deepwater Ocean Mission, and also in their various committees like PAMC and technical review and all that. I'm still closely associated with sea and its conditions. What I would like to look at, or rather what I would like to propose at this juncture is, towards the later part of my career, I was more closely associated with aerospace systems, like our LCA and other things, whichever aircraft that are flying, they're designed and developed by DRDO. One thing I found there is a lot of emphasis and attention being paid to development of digital twins, right? To save the time, to save the cost, and also to reasonably predict as to what will be the effect of environment on the product that is being designed. India, and especially our Navy and our people connected with the ships and submarine design, we are the best. There's no doubt about that when compared to other services. But I also will like to see that, we start working towards more of mathematical modeling of whatever ocean structures we are planning to do, including ships and submarines, and that which will lead to development of digital twins, so that various versions, various combinations can be taken up with a shorter period of time, and also for because we can't keep developing hardware after hardware to learn. That's also costly and time consuming. It's very important that we try to look the applications of digital twin technology for what should I say, offshore structures or naval architecture, whatever it be. This is one thing I thought I should take this opportunity to open up for the consideration of the best of the faculty who are present here today. I'm also really fascinated to see about, of the two things, what interests me is that wind turbine concept or the proposal which the professor talked about. In fact, it is more a coupled problem to solve. And also, I don't know how you take, because, I had worked in Pune also, and with many of the Ministry of Earth Sciences where they deal with atmospheric disturbances and all that. When you talked about cyclone and its components, I am sure that you would have taken into consideration the actual natural phenomenon, what they call it as circulation. Right. That brings in all types of loads at a given moment on the structure what we are mounting. That is, I'm sure that adequate attention and concentration has been given for that. I'm sure that the students who are listening, I want to mention that the government of India is today now concentrating and spending more money for subsurface, because the potential of whatever is available on Earth has been identified and rather reasonably exploited. Now we need to concentrate on seawater bottom and basically underwater. And to that extent, only they have sanctioned nearly more than 4,500 crores for development of that manned submersible of 6,000 meters depth. In fact, it is something equivalent to putting an astronaut in the moon, technology complexity wise. And in that process, more than 450 crores have been earmarked, and it is being already assigned to various academic institutions to take up futuristic areas of research in underwater scenario, all types of, right from engineering applications to ocean energy prediction. There are different verticals. There are about 6 verticals, including biological studies. In fact, I was present in one of the reviews where they were talking about development of drugs by using the bacteria and other things that are found in deep waters. It is going to open up, in my opinion, in fact, a challenging or a more options that are going to be laid out in front of us for the future. And having been in underwater laboratory for more than 28 years, I find it is time that we start working towards that, so that before somebody starts, exploiting the ocean or the underwater this thing, India should take the lead. And interesting enough, this so-called advanced countries have earmarked specific areas in the Indian Ocean and other places where the depths are of the order of 5,000, 6,000 meters. They thought that we cannot go there to do any research work. Hopefully, God willing, by end of this year or beginning of the next year, our own manned submersible will reach 6,000 meters. It is all because of this real thinking and forward-looking ideas being put up by our academic institutes, being converted into actual hardware by, laboratories like NIOT and all the branches of Ministry of Earth Sciences, equally supported by DRDO, ISRO. Everybody is there in the game. And why I am mentioning all this is, this opens up a new panorama of options and opportunities for the present day students to take up and work. In fact, I am not a person from either ocean engineering or naval architecture, and I feel very hesitant to talk. And people like Professor Murali and Professor Manasa is there, but I have been a user. So to that extent, I know what are all the challenges and complexities that will be faced as and when you go in for putting something in the sea. Sea is a very bad teacher, bad master, we used to say, because whatever works in land doesn't work in sea. Due to its own environment and other things. I'm also happy to see that a lot of numerical computations have been brought in to reduce your hardware development and iteration situations. With this, I stop. Thank you very much.
Thank you, Dr. Ramanarayanan.
Are there any queries that we are addressing, Amir?
Yeah, yes, sir. We are seeing a number of questions in the chat box, and we have some and also. Maybe I'll start adding them in the panel, and we can.
Considering the time, yeah, we
Yeah.
can allow
Yeah.
probably 3-4 questions.
Amir,
Yeah.
I would like to
Sure,
quickly
sir.
answer to Dr. Ramanarayanan one point that actually he asked. So I really appreciate he actually pointed out the critical aspect, that is the atmospheric disturbance, which is actually going to play a major role. It is along with the oceanic disturbances when we are actually talking about survival condition and all that. The atmospheric disturbance also is going to play a major role. So far in our study, we have not taken into account the atmospheric disturbance component, but we have already kind of had a meeting with our faculty members in aerospace, because we know that our limitation is in water. So we want to have an expert and discuss together. So that work is almost getting started. We are discussing and finalizing how to proceed further on that. So thank you, sir. Thank you for pointing it out. And it is also useful for all the audience and the participants to also know that, yes, that is also very, very important. Yes, sir. Thank you so much. Yes, Amir,
Yeah,
please.
just another comment to that. Thank you for your valuable comments, Dr. Ramanarayanan. We have also gone. It's usually said that we know much less in the sea than what we know in the space. Therefore, a long way to go, but we are advancing in all the fronts with the effort of different agencies, also the support of government. So now I think we can go to 3-4 questions. First, Apurba Kar, could you
Yeah.
could yeah, go ahead.
Yeah, thank you, sir. Thank you, Professor Behera. It's really a very interesting topic and very stimulating. But I just, I'm a naval actor and I have got experience of around 50 years now. So what I realize is these things are really very challenging technically and also practically. A lot of things are involved in this. It's not only aerodynamics, of course, forms a very important and major part of the full gamut, but there are a lot of other things, systems engineering and many other things are involved actually in this. And what I've experienced, this such kind of a move, we need to have some collaborative approach, because there are some companies in the world who has got a lot of experience, because a lot of experiential factors are involved in this. It is not only analysis, a lot of experience are required, because these are all high stake projects actually. The sea, in the rough sea, we are installing a very high price installations, and it really requires a lot of experiential input. So what just my suggestion from my personal experience is, unless until we go for a collaboration with the companies or the entities who have got some experience, start with the small things. Like I'm telling you, simple things like installation of an offshore wind. In order to install, also forget about design. Just to start to install, there are a lot of things are involved. How you design the ship, how you actually implement, what type of ships are required, and how to gather the data, because we hardly have any data. See, I'm sorry to say that we have got a lot of poverty, not only in money, but unfortunately, India, we have never bothered for collecting data. We have just now started almost maybe, but we have hardly any data. And also, this needs to be integrated with the marine activities. So ships are also involved actually. A lot of specialized ships are also required for installation of such kind of offshore installations, offshore structures. And certain things I think better we avoid, like say wind tunnel, the blade design. There are certain companies in the world, one or two companies who are monopoly, and we should take advantage of that, whatever is already done, rather than starting from the scratch, because that is let us start implementing that, and then we gradually gather a lot of understanding in the whole thing. I tell you, actually, I was involved in OTEC project. There are really many practical issues, like the VIV. Because of that VIV, a lot of clashing was taking place among the pipes, and that was creating so much of fatigue that I can tell you the initial design was, this thing was that the proposal was that 1,000 years. finally we found that it cannot stand even 5 minutes. Within 5 minutes, whole thing will break and fall off. So we got to be very, very careful. That is why I like to say that we need to talk to and also be associated with some companies who have got practical experience in all these things. Because nobody will come forward when you
Yes,
say
sir.
something that we have got a lot of fundamental concepts
Right,
are
sir.
very clear, everything is clear, but since we do not have experience, nobody will come forward to us. That is
Right,
what
right.
suggestion.
So yes, sir, your suggestion is actually very well valid and it's actually true. And especially when we in academic environment, we obviously work on the research aspects first. And in this current scenario, if I say, we start working on our own up to TRL level 3 and so, with some inputs that we get from the industry and all that. But more than that, when we move to TRL 4 and above, we usually tie up with industry and the implementing agencies, and then we start looking at those aspects. Your point is actually very well taken, sir. And yes, that some of the projects, in fact, we have already done that, and this project also, we are in the process of doing it, sir. Thank you so much.
Thank you.
Yes, sir.
Just
Any other
to
question? Yes, sir.
just to sum up that comment, the collaboration between different institutions is very, very critical in this particular aspect. Where VAV is a very common phenomenon known in the academic community, we are not very sure how this got missed out in the designs. So that is where the collaboration and the interaction continuously, rather than working in silos, is a very, very essential thing. Yeah. Next, Anirudh, would you like to go with your question and keep it brief, please?
You can
Anirudh, yeah.
unmute.
Anirudh, go ahead.
Yeah, Mr. Anirudh, we're not able to hear you. Sir, we have Mr. Anirudh's question in the Q&A box also. If he's not
Yeah,
able
we
to
can
speak, we
address
can
that. Yeah.
directly.
You can read it out.
Yeah. So the question is that during the hurricanes and storms, what will be the mitigation measures to protect the wind and wave energy equipments like spar, wind turbine, etc.? So mitigation
Well,
measures, sir. Yeah.
yeah, well, see, there are two aspects to this. First one is design aspects. Usually, as I was presenting in this talk, we should design the system for survival of those equipment or those system during such events. That is one aspect. But even after that, there are a lot of operational equipments or operational systems which are involved. They should also not be damaged. So especially if I talk about some of the blades, especially during cyclones and hurricanes and so on, whether it is in the ocean or land, usually the operation of the turbine is stopped. So the blades are stopped and they will also be aligned with certain angle, and so that the damage due to the strong winds and strong conditions are going to be minimized. So the same thing is going to be done in the ocean, but as we discussed, land and ocean are not going to be the same. So there are certain differences, and based on that analysis and those planning, these blades or the operation of the turbine has to be stopped first, and then it has been designed to survive under those extreme wave conditions and extreme currents and loads. So they will also survive. So it is usually designed for both these conditions. But as we personally, I don't have that knowledge of aerodynamics and the blade and mechanism of that, so I may not be able to comment it appropriately. But yes, there are procedures how to do it, and it is done.
Okay. And the second part of the, it's more of a comment, I think, from Mr. Anu, that in Gulf of Mexico, during storm season, the platforms are shut and towed away from the storm path. So I think he may have, it's more like maybe he's looking for, do we do it for wind
Yeah,
turbine?
I'll address that,
Yes.
Amir. The structures are designed for several exposure levels. The extreme exposure level, there is an operational exposure level for which the structure is functionally designed. I mean, at that scenario, everything will work and everybody can be on board. There are extreme exposure levels for which, as per the design, the structure should stay intact in the place, but it is not fit for operation and occupation. So that exposure level people need to evacuate. And these are all already provided in the API codes and several other codes, even British standard is available. So really during storm condition, there is no protection that is possible. It is actually the design has to cater for the extreme condition that the structure is expected to face. Yeah, we can go to Jyotisman. Jyotisman.
Thank you, Professor Behera. Very nice presentation indeed. Really
Thank you,
enjoyed
sir.
it. And good to see Dr. Ramanarayanan sir and also Professor Murali. Thank you very much for coming here and
Good evening. Yeah.
attending the sessions. My queries are as follows. I have 3 queries. Number 1 is, would it not be more difficult to install the spar compared to the semi-submersible when we consider all the OTEC technology systems installed on board? Otherwise, offshore crane facility will be required at high cost. The second is, will bundled lower diameter pipes not be easily available compared to a high 10-meter diameter cold water pipe? And number 3 is, what is the compared output between horizontal axis versus vertical axis wind turbines? Thank you very much, sir.
Okay, sir, maybe I will give a detailed explanation during our IRS meeting, but before that, I will try to give the answer briefly here. The first question is, if I recall correctly, it is on what is the first question was on semi-submersible can be better than the spar. Yes, correct. So we actually analyzed the spar and semi-submersible both structures depending on depth. Yes, semi-submersible can also be advantageous, but it all depends on depth where we are installing. So if the depth is slightly higher and the stability we want, then sometimes spar is better, because if you look at the overall structure, the dynamics of spar can sometimes be actually better than the semi-submersible in certain conditions. So that's why we initially thought of spar. But depending on, again, as I told, depending on the depth, we can also think of semi-submersible. That is another option. Even one can also think of a vessel. So all the facilities, the OTEC system, everything can be on a vessel, and there also we can have this moon pool and the cold water pipes installed in that. So it is possible, sir. But again, scenario to scenario, this can actually change. This is one of the basically study I have presented. And coming to your next question, that is regarding the bundled CWP instead of single one. Currently, the initial designs which are happening, they are considering single pipe. I have not thought about bundle pipe, but yes, that can actually be looked at and how it is going to change. But when it's actually bundled pipe, then we also have to look at the overall mass and weight of the pipe, because that is going to increase substantially compared to a single pipe. So that impact also have to be really investigated and verified. So I'm not completely ruling out that, but it needs to be investigated. So that is the second question I think you asked. And I'm forgetting the third question that you asked, sir.
Horizontal axis versus vertical axis wind turbines.
Horizontal axis and vertical axis wind turbines. Mostly what we have seen for the large diameter wind turbines, these are all horizontal axis wind turbines which are usually installed. And when it comes to vertical axis wind turbines, their scale is not that big, and the output is not also that high. So far, for this offshore wind turbines, horizontal axis turbine has been looked at as a potential option. So that's why we considered horizontal axis turbine. But Vertical axis turbine, I'm not sure if that large and that high capacity turbines are actually implemented or installed anywhere.
It should be a large number of vertical axis turbines in that case.
Then in that
because
case, the support structure
interference.
also, number of support
Yeah.
structure also have to be there, which could be a challenge.
Yeah.
Jyotisman,
Yes,
for a given
Ye-
foundation and the substructure,
Yes.
the wind capture area in horizontal axis turbine is much larger than the vertical axis turbine, and therefore their aerodynamic performance and the energy conversion rate also will be quite high. So the vertical axis turbine will have its own space where there is limitations for horizontal axis turbine. Otherwise, for large forms, I think we are looking at only vertical horizontal axis turbine. Coming to your question
Yeah.
on spar and semi-submersible, I think finally it will boil down to weather vaning characteristics. The wind continues to change its direction always, so therefore spar will be a much better solution than semi-submersible. Where in a semi-submersible normally you are looking at a 8-point mooring, whereas in a spar you can just live with a catenary single point catenary mooring, or at the max triple point mooring probably. So therefore, spar will have a much better performance in terms of energy capture and also performance, structural and floating performance. Yeah.
So that spar versus semi-submersible question was related to
Yes,
OTEC
yes.
systems. So, yeah. Yeah. No.
Yeah, OTEC system again. It depends on what are the plans that you have. I mean, how much area you need on the deck.
Yeah,
It really
that's
boils
right,
down to
yes,
how
sir.
much area you need on the
Yeah,
deck.
sure.
Yeah, but there may be some comparatively there may be some advantages, but then spar is a much simpler concept. Maybe we can go to the last question, Amir.
Thank you, sir.
Yeah, thanks.
Yes, sir. I think Captain
Santakumar
Bai
I
has
think.
some queries. Yeah, sir, you can go ahead.
Captain Santakumar.
Yeah, good evening, sir. My name is
Good evening.
Shantakumar. I am based in Dubai.
Welcome. Hope you are safe.
I am safe, sir. I am very much
Okay.
safe. Thank you for asking that. My question is with respect to all these offshore installations in the coast of India, west as well as east, and nowadays we have a road and bridge structures being built along the coast. Are these structures taking into consideration the rainwater collection, which can be used for drinking water as fresh water for our municipal public? The next question is with respect to offshore drilling. I'm from the shipping industry, so we carry a lot of crude oil. 2 million barrels of crude oil in one VLCC minimum. And about 700 VLCCs are there. Every day, the crude oil is being extracted from the Earth's crust, and this is being replaced by seawater. What could be the effect of this one? I just wanted to ask whether any studies actually conducted on this aspect.
So, sir, coming to your first question, we have many coastal roads and coastal facilities which are upcoming, and whether we are using rainwater harvesting technique to get drinking water from that or not. Most of this infrastructure which are coming along the coastal locations are coastal roads and so on. And these are not something which are residential buildings. So having rainwater harvesting on this kind of facilities is not possible because it is not possible because of various reasons. One of that is from the road, we cannot really have that water and treat it with a heavy cost and make it drinking water. And that is not being done. Second thing, there are jetties and other facilities where these are all used for various purposes where rainwater harvesting is not. Only if it is residential buildings and so on, there only we can have the rainwater harvesting. which possibly in some of the infrastructures, some of the terminal buildings and so on, it is being done. Coming to your second question regarding replenishing the void of the extracted oil with seawater. So that I do not know exactly whether studies have been done or not, but considering the amount of seawater which goes from the sea, I don't think there is going to be any impact on that. But the seawater going in the underwater aquifers where the oil is being extracted, so that is one way actually important because it is being pushed to actually squeeze out the balance oil. That is also another reason. So it is creating pressure and basically taking out the left out oil if at all is there. So both ways it works. So I'm sure it will be continued as it is being done. I don't think there is going to be any adverse impact on that. In fact, many aquifers in the under the ocean, they are also filled with different brine or different salinity conditions water. So it should be all right. Maybe Professor Murali, if you want to add something onto that.
No, that's good, Professor Behera. I don't have anything to add. Just for the rainwater harvesting purpose, from this infrastructure, I think groundwater recharging could be the main purpose of what the question that Captain Pai was asking. Yeah, that is something that is probably feasible, and I think it's happening. Groundwater recharge probably there is every infrastructure has got a drainage facility leading to the nearby ground or nearby water body or to the sea. So therefore, that's probably happening already. Thank you very much, Captain Pai.
Thank you, sir. Thank you so much.
Thank you, Captain sir.
Narendran, maybe the last question that can be.
Hello, sir. Hello, good evening. Sir, so Professor Behera, nice presentation, Professor Behera. It's nice seeing you again. So just a technical background about the offshore wind turbine experiments that we have conducted in your facility in IIT Madras. Regarding the Reynolds, I think you would have addressed this, like Reynolds and fruit scaling cannot be satisfied simultaneously. But can you shed some light for us? How have you considered this aspect in your measurements?
So I hope you are asking about Reynolds scaling for the.
This kind of questions are not allowed in this forum, Narendra.
Sorry.
This kind of questions are not allowed.
Oh, not allowed. Technical not allowed, sir. Okay.
No.
Go ahead.
It is very well accepted, and I should actually pass on the question to the student who has done the work. But I'll try my best.
Okay, sir. Okay.
See, when you are talking about Reynolds scaling, you are basically asking when we do the scaling within the pipe or cold water pipe flow and all that, right?
No, sir. Sir, sorry to interrupt. So the wind turbine that we have conducted, offshore wind turbine testing in the flume that you have conducted, right?
Yes.
In that one, you are telling that you are generating the thrust force of the blade, and then you are simulating that aspect, right? But where is the Reynolds scaling effect coming into picture? And for the wave simulation, you are considering the fruit scaling, correct? No?
Yeah. For hydrodynamics part, we have considered the fruit scaling, and what you are asking, the turbine rotor thrust and all that. So those corresponding values or the rotor thrust or rotor speed and all that. That calculation was done using the Reynolds scaling and those parameters separately. It was implemented only during so basically the rotor or the fan is being rotated with the required amount of speed to generate the required thrust.
Okay, sir.
It is not
the challenge would be, Professor Behera, the challenge, I think what he is trying to get to is, if you have used the Reynolds scaling, the wind speed would have increased. And the rotations also would have increased because the Reynolds scaling scales the velocity.
We are not using wind.
So just the surface area is what you are taking into account.
We are actually using a motor to rotate the fan, and that rotation is being basically transferred as a kind of dynamics to the system. We are not blowing any wind or anything there.
Okay.
Literally, we are not doing the renewal scaling during that time.
It is only completely fruit scaling parameter. Okay,
Yes,
sir.
You should assume that it's only fruit scaling, Mr. Naval.
Yes. Okay, sir. Okay. Thank you.
I think we can sum up, Amir.
Yes, sir. Yeah,
this.
Yes, sir.
Thank
I would
you.
like to thank all the participants and all those who asked questions. It is really interesting and it's a great learning. Thank you so much.
I should sum up by saying that this discussion has made up the day for all of us, and I'm happy to be here and sharing this session. And also, I'm happy that a teacher is always happy that to see that the student has grown beyond the teacher.
No,
So
sir.
I'm happy to see that Professor Behera has pulled through a lot of difficulties in IIT Bombay to get to here, and they have grown. Also, they have helped the field to grow in a large way in different directions. So, wonderful contributions all round from the group at IIT Bombay, and congratulations and all the best. And thank you, Professor Dr. Ramanarayanan, and thank you everybody, and have a good evening. You can now wind up, Amir.
Sure, sir. Thank you. Thank you
Thank
very
you, sir.
much. Yeah, so I'll spend maybe a few minutes on the vote of thanks. So indeed, it was a very good session. I mean, even I coming from the offshore structure background, so it was really enriching and understanding. So probably it would be good to have some more collaboration with you, Professor. And
Most welcome.
first of all, on behalf of IIT, I would like to thank you all who participated in the webinar. And the participation has been very active. Like a lot of good questions have come up. We have more than 60 registrations, and about at the peak we had around 20 attendees, and some of the attendees were actually conference rooms here, so they were like lot more than that. And we were also streaming this on YouTube, so people were also watching it there as well. And special thanks to the senior members like Mr. J.D. Gupta, Mr. Apurvakar, and others who participated actively in this. And the success has been due to the excellent presentation by Professor Manasa Behera. And thank you, sir, for sharing with us all the research and development happening at IIT Bombay. And we are very grateful to you. Me personally, again, as I said, I have the offshore structure program. I can definitely relate to this and say that this was an enriching session for all of us. Thanks to our chief guest, Dr. Ramanarayanan, who spent his busiest time gracing the occasion and sharing his thoughts as well on the topic and all the different other aspects as well, especially the deep water exploration and what the Matsya, I think you were mentioning the semis.
Mastya 6000.
6,000, yeah. So it's good to know like how we thought uh, and the excellent way it was conducted by Professor Murali as well. I mean, did see some issues initially when Dr. Iyengar had to leave, and then Professor Murali was able to take it forward. I mean, all the introduction without it wasn't planned. I mean, he just pitched in, and it all went really well after that. So we are privileged to have you, sir, with here as well, sir. And finally, I'd like to thank the INE Executive Committee, including Dr. Anger, who tirelessly has been bringing such enriching topics. So we have these sessions every month, and he's able to bring some really good topics, which is good for the INA community. And I'd also like to thank Ms. Selvi and other EC members for the initiatives. Before we conclude, I'd like to bring uh, to notice that we are going to have one national conclave in Mumbai, which is in association with DG Shipping on 10th of April, very soon. Mainly because this is coming from the Indian shipbuilding sector. It's entering into a major growth phase now. And with support from the Government of India, Ministry of Port, Ministry of Shipping and Waterways, etc., there are a lot of new key initiatives that has been brought up. Shipbuilding Finance Assistance Scheme, the Shipbuilding Development Scheme, etc. And together, this provides more than 44,700 crore boost to the domestic capability right now. So this conclave is actually bringing the industry and the national vision together, and we'll be discussing about these initiatives in that conference. So we like to invite everyone, including the panelists and the attendees to this conclave. So this conclave, the goal of is to support the Maritime India Vision 2030 and the long-term roadmap to Maritime Amritkal 2047. So that's the idea. So with this, I'd like to again thank everyone for participation. Have a great day. Thank you very much.
Thank you so much.
Yeah.
And
Thank you, everybody.
again,
Have
thank
a
you,
good
sir.
day.
Thank you, Murali sir. Thank you, Ramanarayanan sir.
Thanks.